100 years ago, the entire course of human history was transformed by one of the greatest inventions of all time. Powered flight. From the Wright brothers' first flight in 1903, history has marveled as the great pioneers like Amy Johnson, Chuck Yeager, Yuri Gagarin, and Neil Armstrong went to the edge in their exploration of the skies. But what of the name Percy Pilcher? Today he lies forgotten. But he could have been more famous than them all, because Percy Pilcher could have been the very first person to fly. He had already defied gravity and soared on the winds. At the age of 28, a young British engineer by the name of Percy Pilcher was setting off to capture the biggest prize of them all. In 1899, a full 4 years before the Wright brothers made the first ever flight, Pilcher had designed and built what he hoped would be the world's first ever powered aircraft. Success would have made him one of the most famous names of our age. Yet, just as he was about to test his aircraft for the first time, fate intervened. Percy Pilcher was prevented from ever flying it, and his original design was lost to history. It is one of history's most intriguing puzzles. Could Percy Pilcher have beaten the Wright brothers and claimed one of the greatest prizes of modern science by being the first person to fly? There is only one way to answer that question: to discover what kind of flying machine he had designed, to build it, and to put it to the test. To complete Pilcher's work, chief designer and test pilot Bill Brooks of Pegasus Aviation designs microlight aircraft for a living. If Pilcher's plane could fly, Bill was the man to fly it.
I'm happy, yeah. 43 kilos of thrust.
Aviation historian Philip Jarrett would lead the investigation into discovering the original details of Pilcher's design.
Well, we have this drawing, you see, as well. Again, we can see the panels there, but the spars disappeared. We have a little bit of a main spar.
And Professor Ian Pohl, director of Cranfield College of Aeronautics, would bring the expertise of the school to the process of actually building the aircraft.
The essence of this task is that we're finishing Pilcher's job off. By the time we go out onto the grass airfield, we should be pretty certain that this can be done.
Percy Pilcher's story began in the age of steam. By 1894, humankind had already conquered the land and mastered the oceans. Yet one final frontier remained: the dream of flight. If you could only master the skies, you would have the power truly to transform the modern world. race was on to win this greatest of scientific prizes. To build a plane that could not only get into the air, but then stay there, and all without crashing. Across the globe, an elite band of scientists and engineers set off on this technology's last great adventure. In America, the Wright brothers and Octave Chanute. In Germany, Otto Lilienthal. And in Britain, the great engineer Sir Hiram Maxim.
The great pioneers were sometimes seen as madmen. They were sometimes seen as great men who were touched by an element of madness. And sometimes they were seen as practical realists who could actually create something. There was a real feeling that now there was a real chance of being able to do it. They would be able to get off the ground. They would get into a third dimension. So it could happen.
It was this elite club of pioneers that the young Percy Pilcher now joined. His days as a naval apprentice had given him a grounding in mechanical engineering. He soon fixed on flight as the great goal of his career.
I think he was just totally fascinated with the idea of flying. I think he knew the risks that were involved and he was prepared to take them.
But the problem faced by all the pioneers was that they had almost no idea of how to do it. There was no science of aerodynamics, no detailed equations that would allow men to do what birds did so effortlessly. Get into the air, stay there under power, and land safely.
The problem with the early stages of flight was that the pioneers were working in a relative vacuum of scientific thinking. So they had the wherewithal to start thinking about the structures for their aircraft. But how to make their aircraft fly was a different matter entirely. They had to start on a clean sheet of paper basis.
As Pilcher began working on these problems, he discovered that one man had gone further than anyone in unlocking the secrets of flight. In Germany, Otto Lilienthal had made a systematic study of birds and had succeeded in translating his observations into a series of simple but elegant gliders. Where everyone else had failed, Lilienthal alone had actually managed to get into the air, to fly, and to land safely.
Lilienthal had succeeded in flying. That's the crux of the matter. And he was the man that any sensible European was going to look to for a lead.
Pilcher went to Germany to meet him. The encounter would change the course of his life. Lilienthal had discovered that it was the curved shape of birds' wings that was the key to the secret of flight. Apply that shape to flying machines, and you would harness the force that allowed birds to soar freely. What he'd understood was the crucial scientific principle underpinning all aircraft: the force of lift. Lilienthal had realized that the critical factor in getting off the ground is how the shape of the wing affects the flow of air across it.
Underneath the aerofoil, the curvature of the aerofoil deflects the airstream downwards. What's perhaps not so intuitive is that over the top of the aerofoil, the air does not go straight on. If that were to happen, then you would clearly create some kind of a void here. And what actually happens when you try and create a void is that more air rushes in and fills that void. So what happens in reality, the air over the top surface is also bent. To do that, the aerofoil needs to apply a force to the air, needs to push it downwards. By Newton's third law, therefore, the air pushes back on the wing and generates the force that we know as lift.
The historian Philip Jarrett began to investigate how Pilcher had translated Lilienthal's work on lift into his own powered flying machine. But when it came to getting details of Pilcher's design, there was very little to go on.
Its configuration, when I started looking at it, was something of a mystery. The trouble is, no drawings and no photographs of the complete machine have ever been seen.
So, in the search for clues, Jarrett decided to investigate the first machines Pilcher had built after meeting Lilienthal. He found that, like his German mentor, Pilcher's early designs were not for powered aircraft at all, but gliders. Pilcher had made a succession of what he called soaring machines, each more daring than the last. The Bat was quickly followed by the Beetle. Pilcher was finally beginning to fly.
He actually began to make reasonably significant flights. We're not talking about flights lasting minutes, we're talking about flights of seconds, but even so, he's staying in the air.
Step by step, Pilcher was improving his designs. Helped by his sister Ella, he began work on a new soaring machine. It would be the culmination of all his glider work to date. He christened it the Hawk. But before the Hawk could prove itself, something happened to bring home just how dangerous the new science of aviation could be. In 1896, there came tragic news from Germany. Otto Lilienthal, the man who had taught him so much, had been killed when he had lost control of his glider.
Unfortunately, he came to grief, and so I have been trying to do justice to him as a pupil. Not in coming to grief, I hope.
With his new Hawk design, Pilcher now set out to prove to the world that he was Lilienthal's fitting successor. Before an invited audience in a field in Kent, Pilcher flew the Hawk over a record 250 yards. It was a sensation. The science journal Nature brought news of his flights to the wider community of pioneers.
Pilcher's record glide in the Hawk was of very considerable importance because it made Pilcher the leader in his field. He had now become the man to catch. He had overtaken what Lilienthal had achieved, so aviation had pushed forward another step.
Percy Pilcher had mastered the first scientific principle of flight: lift. But it was only the beginning. The real prize, true freedom to fly wherever you wanted, still eluded him. What Pilcher needed was power.
Soaring machines are excellent schooling machines, and that is all they are meant to be, until power, in the shape of an engine, is added. One can best compare them to bicycles having no cranks.
The trouble was, in the 1890s, there were no suitable engines. The most widely available were all steam-driven. They had an obvious drawback that made them utterly unsuitable for flight. They weighed too much. But Pilcher was one of the very first to grasp the significance of a new invention that was just what was needed. The internal combustion engine was promising to revolutionize transport. For the first time, here was an engine that was both powerful and lightweight. Pilcher realized it was the breakthrough that could transform powered flight. He now set about building his own engine to fit onto a new version of the Hawk.
I've got an engine in hand of about 4 horsepower, which I think should be enough to keep me in horizontal flight, and I hope in time what are now soaring machines will develop into bona fide flying machines.
As Philip Jarrett went about his research, he found drawings for a new powered version of the Hawk. Pilcher's 2-cylinder engine would sit above the pilot, driving a propeller at the rear of the plane. But then Jarrett discovered that Pilcher had got stuck on a problem that he simply hadn't anticipated.
The dilemma Pilcher faced is a very real problem. If you put an engine into the machine, you increase its total weight.
Weight on the Hawk was already critical. Even a lightweight engine would add to it considerably. If this heavier Hawk was to fly, it would now need more lift. There seemed to be only one possible solution.
The lift basically is related to the surface area of the wing, and as you add more weight, you are demanding a bigger and bigger wing.
The obvious thing to do would be to extend the wing, but that would have consequences.
That puts more pressure onto the structural part of the design, and so a bigger wing is a heavier wing, and therefore you need more wing, and you get into this cycle of a decreasing spiral, which doesn't necessarily have a solution. You don't arrive at a wing which is capable of carrying the pilot, the engine, and the wing's own structure.
It seemed an intractable problem. It would be impossible to make a wing that was big enough, light enough, and strong enough to carry an engine all at the same time. Pilcher was stuck. His cherished Hawk design would never deliver a powered aircraft. Pilcher's dream of powered flight had reached a dead end. He needed a new direction, but which way to go? And then, one day, quite out of the blue, came the beginnings of an answer. Pilcher received a letter from 3,000 miles away.
I shall be very glad to hear from you and to exchange views. I believe success will come only through a process of evolution, and that the present investigators can only hope to be remembered as having pointed the way. Yours truly, Octave Chanute.
Octave Chanute was one of America's leading aviation pioneers. He had read of Pilcher's landmark flight in the Hawk in 1897.
One of the key figures in the early success of aviation towards powered flight is Octave Chanute, who was the great disseminator of information. And Pilcher was very, very fortunate that quite without solicitation, Chanute wrote to him and offered to share data with him.
Pilcher began corresponding with the American pioneer, who had been working on the flight problem, but in a promising new direction. It would revolutionize his entire thinking. Chanute's idea was as ingenious as it was simple. Instead of one big wing, stack several smaller ones on top of one another. That way, you got more surface area, but with a lightweight, robust design.
Chanute provided the solution for him because he could arrange the extra area in such a way that by using cross-bracing, he could produce a stiff, strong structure without adding the extra structure weight. So Chanute's solution saved the weight growth as the wing area required got bigger and bigger.
In the archives of the Royal Aeronautical Society, Philip Jarrett discovered how, inspired by Chanute, Pilcher had designed a four-wing multiplane to be called the Duck. But Pilcher never built it. Instead, Jarrett found that he'd made a number of significant modifications to his design. There were enough tantalizing fragments to piece together details of the new flying machine.
We have Pilcher's preferred power plant installation. We have the quadruplane drawing, and we have some later drawings of parts, one half wing of the finished plane. So we have a specification, a basic specification.
One clue above all was critical. Rather than four wings, the new plane would have three, a triplane. Philip Jarrett was now sure this is what Percy Pilcher's flying machine would have looked like. April 2003, the headquarters of the Royal Aeronautical Society in London. It was the team's first chance to see the results of Philip Jarrett's historical research.
We have this drawing, you see, as well.
Right.
So this could have been the one, and the fabric runs round it.
Just the wing root.
Yes.
This is the root.
Well, this is the centre, part of the centre section.
This was the first step on the road to answering whether or not Percy Pilcher could have been the first person to fly.
These cutouts in the wing just look
Yes.
look crazy.
Curious.
I mean,
Yeah. Well, they come from Chanute. There's Chanute's inspirational quadruplane.
which we couldn't quite fathom.
And the Chinook machine did have rather strange panelled wings.
Yeah.
But
we don't have any elevators on this,
no,
do we?
no elevators,
Purely
no
weight
rudders.
shift.
Crikey.
Yeah, it's really strange because the machine itself looks like it will fly, but there are big gaps in it which I'm bothered about.
To help answer that fundamental question, will it fly, Bill Brooks decided to build a scale model of the triplane.
Ah, stall. Oh. Pilcher dies again.
The triplane model flew,
Well,
just about. But there was clearly a problem. The angle of descent was far too steep.
4, 5, 6. It's hitting the ground about here. So I think that the angle of descent is about 3 to 1. And that's fairly poor performance. That's a little bit better than a brick.
It seemed that for all the ingenuity of Pilcher's design, something wasn't right. The problem identified by Bill Brooks was one of lift. At Cranfield, the team decided to run a wind tunnel test to get to the bottom of what was wrong with the triplane's lift.
Okay.
The Pilcher plane, it's an aeroplane that is operated on the very limits of Bill's ability to fly. Because we're close to limits, we need to be more confident about the numbers we're actually dealing with.
Ian Pole then wrangled with the results from the wind tunnel test. It was decision time for Pilcher's triplane design.
The analysis tells us some good news and some bad news. The good news is that the triplane behaves very much like a conventional aeroplane, in fact, surprisingly so. I expected it not to be as well behaved as it is. That's the good news. The bad news is that it's telling us that we probably need more wing area than we have on the original design, because we haven't really got enough lift for the speeds at which we aim to operate.
The cause of the lift problem lay in something bewildering about Pilcher's design. Inspired by Chanute, he designed each wing to have triangular cutouts, slashing the wing area, and so the lift, something he'd never done on his earlier gliders.
From the very beginning, we were puzzled about the need for the wing cutouts. And since we haven't really come up with any good explanation for having them there, the simplest way of increasing the wing area is to fill in those gaps.
Bill Brooks decided to close the cutouts on his scale model, boosting the wing area by 12%. The team believed they were justified in doing this, as Pilcher had always flown with a complete wing on his earlier designs.
I don't think that it's diverting too much from historical accuracy to get rid of these very big gaps. It appears to me that Pilcher would have discovered in 1 or 2 days of testing that chopping half his wing area away was a bad idea on a foot-launched flying machine. And so I think that we'll start off with full covering. pray that it doesn't go left. And pray that it doesn't go right too much. There's Percy Pilcher himself. Let's see what we've got now. Oh, perfect.
Ah, here we go. Oh, oh, oh. Oh, Bill, you're fighting a losing battle here.
No, he's all right, he's all right. Oh, cripes. Ah, whoa! Oh! I think there's a flying machine in there somewhere. With the cutouts gone, the wing area's increased and we get slower stall speeds. I've had to increase the tail area a bit in order to get it to be stable in pitch. But compared with the Wright Brothers Flyer, for example, this is a much more viable aircraft configuration, and in fact it's quite advanced in my view. It actually looks something like an aeroplane.
To power the triplane, the team chose a small modern engine, leaving Bill Brooks one final task: finding a propeller. Before the invention of the jet engine, propellers were the only way to push an aircraft through the air. But in the 1890s, no one had ever made one before. The Science Museum at Wroughton has one of the earliest examples. It is thought to have been Pilcher's inspiration.
Ah.
Well, here it is, Bill, Maxim's propeller.
Well, the diameter looks to me to be around 15 feet.
It's actually 17 feet 10 inches in diameter from tip to tip.
That's more than half the span of our triplane.
Right.
So,
The vast propeller was built by Pilcher's one-time employer, Sir Hiram Maxim, for the colossal and never-to-fly kite of war. It was clear the design would have to be radically adapted if it was to work on the much smaller triplane.
it would have been fairly obvious to him that the propeller would have to be scaled to the engine and also to the speed at which the engine is turning the propeller. So we could build a propeller of this kind of plan form, but it will come out looking much more like a toothpick than a paddle.
With the last detail in place, the construction of the plane could finally begin. Back in 1899, from his base at Stanford Hall, Percy Pilcher was also approaching completion of the very same aircraft. But the move into powered flight had not just taken him into whole new areas of science, it had also taken him into debt. Pilcher needed money. So, to raise funds, he decided to fly his new triplane in front of some potential backers.
The obvious thing was to gather any influential people or wealthy people who might be interested in the possibilities of powered flight and prepared to make some investment, not necessarily enormous, but just something.
The date of September the 30th was set for the triplane's display. It would be her maiden flight. But then, just days before the display, a setback. The new engine Pilcher had painstakingly built from scratch broke down. It meant he would not be able to demonstrate the triplane after all.
It was a disaster, but not a major disaster. they could still show Pilcher flying a glider, they could still show a new machine. It was a disappointment, I'm sure.
Pilcher was determined not to let down his guests. So he put on a display of his trusted glider, the Hawk.
He tried a couple of launches, and during that process, either from the damp on the ground or from perhaps some rain in the air, the glider had apparently become damp, and therefore it would have made quite a difference to the weight of the thing. It went up nicely. I think it was the third attempt. It was going up quite well, reached somewhere between 30 and 50 feet. And then there was a very loud crack. People who were watching from the front saw the glider's wings fold up and the glider plummet to the ground with a very heavy thud.
Pilcher, unconscious, was rushed to the hall for treatment, where 2 days later, he died. So it was that 4 years later, all the glory would go to two Americans. On December the 17th, 1903, at Kitty Hawk in North Carolina, Orville and Wilbur Wright triumphed with the world's first ever sustained, powered flights. Their longest flight lasted 59 seconds. It would buy them their place in the history books. As for Percy Pilcher, he lay forgotten in a London cemetery. In the aftermath of his death, his triplane was abandoned and left to rot away. Yet the tantalizing question remains. Had Pilcher not been tragically killed, might he have been the first person to fly? Over 100 years after his death, Pilcher's bold, powered triplane was finally ready.
It is a fantastic looking machine. It is a real wacky racer. Really, he deserved to try it out, didn't he?
But there was one final issue still niggling Bill Brooks.
This one, yeah. Right, and again.
As the test pilot who would be putting his neck on the line, Brooks was worried about Pilcher's system of controlling the triplane. To get an aircraft to fly without veering uncontrollably left, right, or straight into the ground was one of the great breakthroughs on the road to powered flight.
The problem with an aeroplane is that it moves around in 3 dimensions.
It can also roll, it can pitch, and it can yaw. And the skill in designing control systems is to make sure that the forces are applied in combinations which give you the desired maneuver. Very difficult.
Pilcher had controlled his gliders through balancing the aircraft by shifting his body weight. But Bill Brooks was concerned that body shift alone might not be good enough for the heavier powered triplane.
Basically, right, you support your weight like this, and that is Pilcher's flying position. And to slow the aircraft down, you pitch up like that. The trouble is that if the aircraft pitches up to that sort of angle, and you try and get the nose down again, it becomes almost impossible.
If you can't get the nose down, you lose control and crash. But there was a simple refinement that Pilcher would have been aware of, developed by Chanute for his triplane. A swinging seat to take the pilot's weight.
Seems crazy to me, given that they had decided to control an aircraft by weight shift, not to hang from something and give themselves a decent lever arm by which to move the weight around in the airframe.
The team decided to install a Chanute-inspired swing seat on the triplane. But to be absolutely safe, Bill Brooks went one step further.
I've decided to add a system which was developed after Pilcher, really, called wing warping. And the Wrights were the first people to really exploit wing warping. When I move, say, to the left, I pull on this string, because it's connected to my strap here. That pulls that wing down to achieve roll control.
August 2003. The plane was at last ready to fly. The time had come to find out if Percy Pilcher could have been the first person to achieve powered flight.
Right. Okay, that's fine. That's nose into wind. All right.
The target to beat, 59 seconds. The best time clocked up by the Wright brothers in their inaugural flights.
Choke off.
The triplane flies. It was only 7 seconds, but that was just 5 seconds behind what the Wrights achieved on their very first attempt. It was time for another go.
Yeah, that's a shame. How much damage?
This rib spot.
Okay, okay.
Chip strut on the middle.
Never mind. Quite quick to repair. Okay, Dan?
A week later, it was the last chance for Pilcher's triplane.
We've repaired the spar and a couple of ribs, recovered the bottom wing panel, and it's pretty much as good as new now.
The test flight taught Brooks some valuable lessons about the handling of the aircraft under power. Just as Percy Pilcher could have done, The team made a number of small adjustments to improve the triplane's stability. One was critical.
Because the prop goes round that way, you have a torque reaction on the whole airframe which makes it roll right. So we've put a kilo of lead out on the tip to counterbalance the torque reaction. So that should sort that out. Switches on.
Although Bill Brooks still had the Wright brothers' control system installed for safety, he was confident the plane would fly on a calm day without using it.
Horizon 1 tower, how do you read?
Then it was time to open the throttle.
All right. Yay! Flies! Yee-haw!
1 minute and 25 seconds. The Wright brothers managed 59 seconds on their best flight of December the 17th, so that's pretty good.
I've pilched!
I thought that Percy Pilcher deserves a little more credit than perhaps he's been given up until now.
He wasn't that far off doing it, was he, when you see that? And I was just limited by crashing in the garden of that house over there, really.
No one can be sure that Pilcher would have made the small refinements, but there's now no doubt that his triplane could have flown. It means, had fate been otherwise, Percy Pilcher could have been one of the greatest names in the history of aviation.